In this video, I will express the x of t signal in terms of x1 of t and x2 of t signals. And determine the Fourier transform. Fourier transform of that signal x of t. That signal x of t. X of t. Here x of t function is waveform is like that. X of t is equal to this one is x of t 1.5. The x1 of t is equal to -1/2, 1/2. This one is x1 of t. Dx is this one is here 1, x2 of t -3/2 to 3/2. 3. Okay. Here the values here is 1, 2, 3, and 4. This is the x of t, x1 of t, and x2 of t. Solution is consider x1 of t. Here -1/2, 1/2. Here 1, x1 of t. Okay, change it to here 2 under 3. Here these are 2 second and the third values. This implies shifted right side. That means shifted right side means you have to find out the shifted value x1 of t. That is -1/2 plus k plus 1/2 plus q. -1/2 plus k is equal to 2. -1/2 plus k is equal to 2. Original function 2 in x of t. That is equal to k is equal to 2 plus 1/2. 2 to 4 plus 1, that is 5/2. Here 1/2 plus k is equal to 3. Consider this one and this one for x1 and t. Therefore, k is equal to 3 minus 1/2. 3 into 2, 6 minus 1/2. That is equal to 5/2. K value is 5/2. Therefore, finally, x1 of t changed to x1 of t minus k. K is 5/2. T minus k is 5/2. The function is like that. The function is x1 of t minus 5/2 is here 2 comma here 2 and 3. The value is amplitude value is 1. Here x1 of t minus 1/2 to 1/2. The value is 1. Some shifting operation because why? Because x1 of t in terms of x of t. Here 2 and 3 is considered. 2 and 3 is considered. That is the reason minus 1 by 2 plus k. Shifting right side direction. That is the reason we use plus k plus 1 by 2 plus k. Find out that k value in both the points. Shifting points here 2 and 3 is the shifting points. X1 of t minus 5 by 2. I'm coming to next one. Consider x2 of t. X2 of t is equal to given function is x2 of t minus 3 by 2 to plus 3 by 2 minus 3 by 2 to plus 3 by 2. Here value is 1. For this function x2 of t, consider this 1 and this 4. For x1 of t, consider this 2 and 3. Okay. Now here again shifting right side direction. X2 of t minus k. Find out k value here. Here minus 3 by 2 plus k. Suppose 3 by 2 plus k. Minus 3 by 2 plus k is equal to 1. That is 1. This is the waveform. This is the waveform, shifting waveform. That is in here. Minus 3 by 2 plus k is equal to 1. Therefore, k is equal to 1 plus 3 by 2. That is 5 by 2. And 3 by 2 plus k is equal to 3 by 2 plus k is equal to 4. 3 by 2 plus k is equal to 4. Therefore, k is equal to 4 minus 3 by 2. 4 2s are 8 minus 3 by 2. That is 5. K is equal to 5 by 2. In both the cases, k is 5 by 2. Here 1 and 4. Therefore, here x2 of t minus 5 by 2. X2 of t minus 5 by 2. The value is here 1 and 4. This is x2 of t minus 5 by 2 minus 3 by 2 to plus 3 by 2 change it to 1 comma 4. 1 comma 4. Here minus 1 by 2 to plus 1 by 2 changes to 2 comma 3. Here original function, this one is x of t function. X of t is here 1, 2, 3, 4. Here 1.5, here 1 is the combination of x1 of t minus 5 by 2. X1 of t minus 5 by 2. Here x1 of t minus 5 by 2 is 2 comma 3. Here 2 comma 3. Here 1. And x2 of t minus 5 by 2. X2 of t minus 5 by 2 is 1 comma 4. Here 1. 1, 2, 3 and 4. Here 1. Suppose add these two. Add these two. We will get this one. X of t. Suppose x of t is equal to. For x is equal to t is equal to 1. T is equal to 1. Here t is equal to 1. This one is 0 plus 1. That is t is equal to 1. The value is 1. Okay. At t is equal to t value lies in between 1 comma 2. T value lies in between 1 comma 2 means here 1, 2. P value is relation between 1, 2. X2 of t minus pi by 2 is 1. X2 of t minus pi by 2 is 1. X1 of t minus pi by 2 is 0. 0 plus 1 is 1. Therefore, in the limit of this one. Okay. In the limit 2, this one is satisfied. 1 to 2 satisfied. And 2 at 2 t is equal to 2. Here the value is 1. Here the value is 1. 1 plus 1 is 2. But here the value is 1.5. That is the reason here we use 1 by 2. Here we use 1 by 2. Here we use 1 by 2. 1 by 2 is 0.5. Okay. Now, in the interval at t equal to 2, the value of x2 of t minus pi by 2 is 1. The value of x1 t minus pi by 2 value is 0.5. 1 plus 0.5 is 1.5. In the interval 2 less than or equal to t less than or equal to 3, x2 of t minus pi by 2 value is 1, and x1 of t minus pi by 2 is value is 1 by 2, that is 0.5. Therefore, 1 plus 0.5, 1.5 satisfied. Into this point at t equal to 3, here the value is 1. At t equal to 3, here value is 0.5. At t equal to 3, the value is 1. Here 2, 3. At t equal to 3. At t equal to 3 less than or equal to 3 less than or equal to t less than or equal to 4. Here the value is 1. Here the value is 0. That is the reason here we use 1. Maintain 1. Maintain 1. At t equal to 3. At t equal to 3, here the value is 1.5. At t equal to 3. Okay. At t less 3 less than or equal to t less than or equal to 4. Here is 0 and 1. The value is 1. That is the reason maintain 1. At t equal to 4. At t equal to 4 here is 0, here is 1. Therefore, the value is 1 at t equal to 4. Therefore, all are satisfied. Finally, x of t is expressed in terms of 0.5, that is 1 by 2 x minus t minus x1 in t minus pi by 2 plus x2 into t minus pi by 2. X of t is a combination of 0.5 x1 into t minus pi by 2 plus x2 t minus pi by 2. Find out Fourier transform of x of t. Fourier transform of x of t. First, to find out Fourier transform of 0.5 x1 into t minus pi by 2. That is 1 by 2. Fourier transform of x1 into t minus pi by 2. That is equal to, using a shifting property, x of t minus t naught Fourier transform is e power minus j omega t naught Fourier transform of x of t. This property is applied here. Shifting value is pi by 2. E power minus j omega pi by 2. Therefore, Fourier transform of x1 of t. Here in that figure, x1 of t is here minus 1 by 2 to 1 by 2. The value of x here x1 of t is in that interval, the value is 1. Draw this one waveform, x1 of t waveform, minus 1 by 2 to 1 by 2 t. This is x1 of t. The value is 1. Find out the Fourier transform. Fourier transform of x1 of t is equal to minus 1 by 2 to 1 by 2. The value is x1 of t is value is 1. E power minus j omega t dt. That is equal to e power minus j omega t pi minus j omega 1 by 2 to minus. Substitute these values here. E power minus j omega 1 by 2 minus, here minus sign is there, minus j omega, minus into minus plus e power j omega, here minus into minus plus j omega by 2 by j omega. Here 2 by omega. Here this one is e power j omega by 2 minus e power minus j omega by 2 by 2z. Omega bring outside 2 is divided, multiplied numerator and denominator. Therefore 2 by omega sine omega by 2. This one is a Fourier transform of Fourier transform of x1 of t. Fourier transform of x1 of t. Therefore, finally Fourier transform of 0.5 into x1 of t minus 5 by 2 is equal to 0.5 into e power minus j omega 5 by 2 Fourier transform of x1 of t. We know that 0.5 into e power minus j omega 5 by 2 Fourier transform of x1 of t is 2 by omega sine omega. And find out the Fourier transform of x2 of t minus 5 by 2. x2 of t minus x of t is the combination of 0.5 x1 t minus 5 by 2 and x2 t. Next, find out the Fourier transform of x2 of t. x2 of t minus 5 by 2. x2 of t minus 5 by 2 is equal to apply shifting property e power time shifting property j omega, shifting value is 5 by 2, Fourier transform of x2 of t. We know that x2 of t is equal to minus 3 by 2 to 3 by 2. The value is 1. This is the x2 of t. Find out the Fourier transform of x2 of t. Minus 3 by 2 to plus 3 by 2 to the value is 1. E power minus j omega t dt. Therefore, e power minus j omega t by minus j omega 3 by 2 to minus 3 by 2. Here, this one e power minus j omega 3 by 2 by minus j omega minus into minus plus e power j omega 3 by 2 by j omega. Here numerator and denominator is multiplied with again e power j omega 3 by 2 minus e power minus j omega 3 by 2 by 2z. Therefore, this one is 2 by omega sine 3 omega by 2. This one is Fourier transform of x2 of t. Therefore, Fourier transform of finally Fourier transform of x2 of t minus 5 by 2 is e power minus j omega 5 by 2 and the Fourier transform of x2 of t. Fourier transform of x2 of t. E power minus j omega 5 by 2 Fourier transform of x2 of t is 2 by omega sine 3 omega by 2. Fourier transform of 0.5 x1 of t minus 5 by 2 is 1 by 2. 0.5 is 1 by 2 e power minus j omega by 2. J omega 5 omega by 2 And Fourier transform x1 of t is already derived 2 by sine omega, no, 2 by omega, here 2 by omega, sine omega, 2 by omega, sine omega by 2. Add these two. Fourier transform of x of t is equal to Fourier transform of 0.5 x1 of t minus 5 by 2 plus Fourier transform of 2 into t minus 5 by 2. Here the value is 1 by 2 e power minus a 5 omega by 2 with this one, 2 by omega sine omega by 2 plus next one e power, this one e power minus j 5 omega by 2, 2 by omega sine 3 omega by 2. Finally, x of t is f of Fourier transform. Here 2 cancel. E power minus 5j omega by 2 or e power minus a 5 omega by 2, 1 by omega sine omega by 2 and e power minus j 5 omega by 2 into 2 by omega, not 5, 2 by omega sine 3 omega by 2. Here e power minus j 5 omega by 2 is common term and also sine omega by 2 plus 2 sine 3 omega by 2 by omega. This is the Fourier transform of x of t. Here x of t is here. Here x of t is waveform is like that. Here x of t waveform is 1, 2, 3, 4, 1, 1.5. This is the Fourier transform of x of t. If you like this video, please subscribe the channel for further updates. Thank you.